Lesson 1. What is the global atmospheric circulation? What is it? Global atmospheric circulation is a large-scale movement of air by which heat is distributed on the surface of the Earth. The wind belts and the jet streams girdling the planet are steered by three convection cells: the Hadley cell, the Ferrel cell, and the polar cell. How does it work? Over the major parts of the Earth's surface, there are large-scale wind circulations present. The global circulation can be described as the worldwide system of winds by which the necessary transport of heat from tropical to polar latitudes is accomplished. In each hemisphere, there are three cells: Hadley cell, Ferrel cell, and polar cells, in which air circulates through the entire depth of the troposphere. The troposphere is a name given to the vertical extent of the atmosphere from the surface right up to between 10 and 15 kilometers high. It is the part of the atmosphere where most of the weather takes place. Hadley cells are the largest cells, extending from the equator to between 30 and 40 degrees north and south, and are named Hadley cells. Within the Hadley cells, the trade winds blow towards the equator, then ascend near the equator as a broken line of thunderstorms which forms the Intertropical Convergence Zone, ITCZ. From the tops of these storms, the air flows towards higher latitudes, where it sinks to produce high-pressure regions over subtropical oceans and the world's hot deserts such as the Sahara Desert in North Africa. Ferrel cells are middle cells, which are known as Ferrel cells. Air converges at low altitudes to ascend along the boundaries between cool polar air and the warm subtropical air that generally occurs between 60 and 70 degrees north and south. This often occurs around the latitude of the UK, which gives us our unsettled weather. The circulation within the Ferrel cell is complicated by a return flow of air at high altitudes towards the tropics, where it joins sinking air from the Hadley cell. The Ferrel cell moves in the opposite direction in the two other cells, Hadley cells and polar cells, and acts rather like a gear. In this cell, the surface wind would flow from a southerly direction in the northern hemisphere. However, the spin of the Earth induces an apparent motion to the right in the northern hemisphere and left in the southern hemisphere. This deflection is caused by the Coriolis effect and leads to the prevailing westerly and southwesterly wind often experienced over the United Kingdom. Polar cells are the smallest and weakest cells, known as polar cells, which extend from between 60 and 70 degrees north and south to the poles. Air in these cells sinks over the highest latitudes and flows out towards the lower latitudes at the surface. So how does it affect the world's weather? Warm, moist air from the tropics gets fed north by the surface winds of the Ferrel cell. This then meets cool, dry air moving south in the polar cell. The polar front forms where these two contrasting air masses meet, leading to ascending air and low pressure at the surface, often around the latitude of the UK. The polar front jet stream drives the area of unstable atmosphere. The UK and many other countries in Europe often experience unsettled weather, which comes from travelling areas of low pressure, which form when moist air rises along the polar front. Weather or low pressure systems bearing rain and unsettled conditions move across the Atlantic on a regular basis. The jet stream guides these systems, so its position is important for UK weather. In summer, the normal position of the jet stream is to be to the north of the UK, dragging those weather systems away from our shores to give us a relatively settled weather. Normally, the jet stream runs fairly directly from west to east and pushes weather systems through quite quickly. However, sometimes the steering flow of the jet stream can meander a bit like a river, curving north and south as it heads west across the Atlantic. This is called a meridional flow, with more linear west to the east flow called a zonal flow. During a meridional flow, areas of low pressure can become stuck over the UK, leading to prolonged periods of rain and strong winds. During the winter, polar front jet streams move further south, leading to the greater risk of unsettled weather, and even snow if cold Arctic air masses move south over the UK. The continued effect of the three circulation cells, Hadley, Ferrel and polar cells, combined with the influence of the Coriolis effect, results in global circulation. The net effect is to transfer energy from the tropics towards the poles in a gigantic conveyor belt.